Hello and welcome. My name is Mr. Brash, and this cute little orange guy over here is Mr. Squirrel, and we've been doing some math videos the last little while, and I've got a doozy for you here. This is solving quadratics when they don't factor, part 1. And there's going to be a second part of this, different way to do it, but this video is going to focus on the first way of doing it, which is sort of the classic way of solving any sort of quadratic from standard form when it doesn't factor. So it's going to be a little bit of a tough video. It's going to be a longer video, and there's going to be a portion that you can choose to skip. I'll get to that in a second. All right, if you're watching this video, it's because you already know a little bit about quadratics and you've seen them in standard form before. And if you haven't, and if you don't know what I'm talking about, this won't be for the faint of heart. You might want to move on. Check out some of my previous videos. Check out some Khan Academy videos about quadratics and parabolas. At this point, you should be good with solving for zeros, this idea of finding the x-intercepts from standard form. And at this point, we know two ways to do it. We can factor it. So on the left-hand side here, I've got an example of factoring it. We've got this trinomial that happens to factor, and the factors are 14 and negative 2. And that way we can get our zeros of negative 14 and positive 2. And hopefully, this either just rings a bell or you've seen this before or something like that. We also should know how to solve when it's actually in vertex form. So if we take a look at it from this side here on the right-hand side and this particular line, this is vertex form, and you should be able to solve it from vertex form by moving things over to one side and taking the square root of both sides at some point. But from standard form, which is the first line here from standard form, we would need to do something called complete the square. I do have a video on that. Khan Academy has a fantastic video series on that. And I sort of breezed over the concept of completing the square here just so it would fit on the screen. So there's a couple steps that were skipped here, but if this was my standard form right here, we would complete the square to get it into vertex form, which is this line here that I talked about before. And we would solve by moving things to one side of the equal sign and, taking the square root. That taking of the square root is really important. And I want to focus on this right here, which you would have seen before from solving where we have a positive or negative value. In this particular example, what I'll end up with is x equals negative 7 plus that 2.12. Or I'll have x equals negative 7 minus that 2.12. This adding and subtracting the same value is what I want to focus on. When we have a parabola, let me just sort of draw, here, let's see what I can do here. Let's just draw a Cartesian plane, a fake Cartesian plane, and I'll just draw a fake parabola. We'll just do a parabola right here. And I've got an axis of symmetry that goes right down the center of my parabola with a vertex. Those two zeros that we keep talking about, they're really crucial points. Roots, zeros, anything that is on either side of the vertex are the same distance away from each other. That means the left zero is a certain distance away. I'll just put 3 sort of humps here. And the one on the right would be also 3 humps away. That is a crucial thing to understand when we start taking a look at the square root that gives us a positive and a negative. In this case, I'm going to go to the right 2.12 from some arbitrary value of negative 7, and I'm going to go to the left of 2.12 from some arbitrary value of negative 7. This is not necessarily the vertex, but the concept of adding and subtracting the same value is really crucial for this lesson and for the next one as well. Now, completing the square is useful, and it does get us to vertex form, but it's messy. Completing the square is messy and has a lot of opportunity for algebraic error. And not only that, it's a lot of steps. You got to take your greatest common factor, cut some middle value in half, square it, add it, subtract it, solve. It's a mess. And especially when it gets into fractions like what I have here. If I've been asked to solve this from standard form, my first thing that I should be doing is taking out my a value, which is 3. So I would factor everything by dividing by 3, and that gives me 7 over 3, which is not a fun fraction to work with. I would, divide by 3 on both sides so that it's gone, because 0 divided by 3 is 0. But now I'm left with this 7 over 3. If I want to continue to complete the square on this, what I'm going to need to do is cut 7 over 3 in half. So 1/2 of 7 over 3 is 7 over 6. And now I have to square that, which is 49 over 36. I have to add and subtract 49 over 36 from this everything is just getting messy. So I'm going to say that this is getting too messy. It's too much work for me to find the zeros. That's where today's lesson comes into play. Enter the quadratic formula. Bum, 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 bum. And it looks way more complicated than it actually is. It's easy to memorize. You can, there's songs you can sing. There's all sorts of different ways to memorize this. But the quadratic formula is one of the most important formulas in sort of generic everyday algebraic and geometric mathematics. I'm not talking about, the crazy theoretical mathematics out there, but this is a really important formula that pretty much every mathematician uses constantly. The idea here is that this is a representation of standard form. This is standard form that has already been simplified, so it's been turned into vertex form, so it has completed the square. We've completed the square on the equation, completed the square, and solved for x, so isolated x. And you can see that there's a plus and a minus, and that comes from the square root. So standard form is your typical, y equals ax squared plus bx plus c. And you can see those three important values. A is in the formula, b is in the formula, and c is also in the formula. So this is just a manipulation of y equals ax squared plus bx plus c to get it into this form. And what does that do for us? Well, it gives us the zeros. That is exactly what the quadratic formula does. Now at this point, I'm going to show how the quadratic formula even gets created, but you don't need to know that. I am going to show the derivation of it. It's a bit tricky. If you want to skip this next portion, I'll have a timestamp in the description of this video as to where the derivation ends, and you can go straight to my first example of using the quadratic formula to find zeros. But for now, I'm going to go over the derivation. Okay, so we've got the standard form, and it's equal to 0 because we're solving for the zeros. Now, the first step is to complete the square. We're going to assume it's not factorable, and this is where the quadratic formula becomes a crutch for some people. Some people see a standard form equation, they immediately go and use the quadratic formula. I don't think that's useful. If it factors, factor it. But in this case, we're assuming it doesn't factor. And so we're going to complete the square. And the first step of completing the square is taking your a value out of the equation. Now, in this case, I only take it out of the a and the b because you can partially factor when you're completing the square. So we'll just ignore sort of any difference from what you've seen before in completing the square. So now that I've factored my a out of the a and b, you'll see that b has become b over a. And that's because I had to divide b by a. Okay, great. Now I have to do the actual fun sort of magic number of completing the square. So I'm going to take half of my b over a and square it. Now let's just think about that for a second. Half of b over a, so half of b over a would be b over 2a. Pretty simple, right? You're just going to multiply these two fractions. But now I need to square it. So I need to square my numerator and I need to square my denominator. So I'm going to square b and I'm going to square 2a. And I end up with b squared over 4a squared. Now that I've got in this box here is the magic number that sort of comes back when we're continuing to complete the square and we add and subtract that value. That's the value that is, creatively adding nothing, creatively adding 0 when completing the square. Now, in order to finish off the completion of the square and factor the trinomial that I have here, I have to take the negative value out, multiply it by a, and stick it on the end. Normally we wouldn't, if you're used to completing the square in a different way, you wouldn't have to multiply by the a. It would have already been multiplied by the a. But anyway, if I multiply b squared over 4a squared times a, it just cancels out one of the a's in the denominator. So I'll have b squared over 4, but it is negative. So I'm going to see a negative ab squared over 4a squared, and these a's will cancel. All right, so just to clarify here, I took the negative one, multiplied by a, put it on the end. That's what you see right here. In the next step, you'll see that, in fact, the a is canceled. Now we're doing something else. We're doing a few things in this one step. I'm just trying to keep it sort of short, even though it's not short. So we're going to take this trinomial, we're going to factor it. Now there's no crazy factoring here because we know what we need to put in. It's the half of the b over a, and that's from completing the square. So that b over a becomes b over 2a. Now before squaring it, that's the value that goes into your perfect square. So we've created that perfect square from this trinomial. It's not that bad, it's not that messy. But why is there a 4ac over 4 here instead of just my c? I'm using common denominator in order to do this subtraction. So the common denominator is going to be 4a because the a's canceled. So I just created a common denominator for my c here. Because we're going to do this subtraction, we're going to have 4ac minus b squared. So over down here, we're going to see 4ac minus b squared, and that's all over 4a because that's my common denominator. All right, moving on. That right there, that's vertex form. What we see here is we've got our a value, we've got our perfect square, and we've got our k value. So this 4ac minus b squared all over 4a, that's the y value of your vertex. Incidentally, b over 2a, that's the x value of your vertex. So this entire time, negative b over 2a, when you take a look at your standard form here, is the x value of your vertex. We could have been doing this the entire time just to get the x value and y value of your vertex. In any event, we've got vertex form and we need to move on. We need to solve for x. Because we want to solve for the zeros, so we're going to get x all by itself. For the first thing you're going to want to do is move this over to the right-hand side. So we're going to subtract this on both sides of the equation. Great. So I took this horrible fraction, subtracted it on both sides. What does that mean? Well, it means I've got a negative outside, so I really should apply this to the items on the inside. So let's apply that negative to the items on the inside of the bracket. So that turns my 4ac negative, and it turns my negative b squared positive. Not a big deal. Now I'm going to divide both sides by a. And I'm also going to move my positive b squared to the front. Not particularly horrible. You'll see b squared comes to the front, so negative 4ac goes to the right. That's because the b squared is positive, but also because it has a higher degree on it, and we want to see the higher degree items at the front. I'll divide by a on both sides, which gives me 4a squared. Now I'm at the point where I can do the magic of taking the square root of both sides. Sweet, right? Now, of course, we know that when you take the square root of both sides of something, you take the square root of anything, you're going to get a positive and you're going to get a negative. So I'll get to that in a second, but I wanted to keep the sort of the nomenclature simple here. So I can do the square root of some of the items, actually only the denominator, on the right-hand side. I can take the square root of 4a squared. It's really easy. It's 2a. Now, technically, that's where my plus and minus should come from. And I'm not able to really cleanly take the square root of b squared minus 4ac, so we're just going to leave that. We're just going to leave that there. That's actually called the discriminant. Maybe I'll talk about that in another video. Taking the square root of the left-hand side is super easy. It just cancels out the square. So I'm left with this x plus b over 2a, and that negative b over 2a is your x value of the vertex. All right, the last thing I need to do is subtract this on both sides, and the beauty is I already have a common denominator. I already have 2a as a denominator, so I'm going to subtract b over 2a on both sides, but don't forget that this is positive or negative because of the square root that I did on the denominator. I've got negative b over 2a plus or minus this stuff over 2a, and that can be combined because it's a common denominator. So we get the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're going to need to use this all the time. You're going to have to memorize it, but more importantly, you're going to want to understand it. So that was the derivation, or how we get this formula, and the pieces of the formula are really important. I said I'd mention the discriminant in another video, but maybe I'll mention it right now. So the x value of the vertex, is this portion right here. That actually gets you the x value of the vertex from standard forms. That's negative b over 2a. The stuff underneath the square root is called the discriminant. That tells me how many zeros I'm going to have. Because square roots are kind of funky and you can only take the square root of positive numbers, if I ever end up with a negative value underneath my square root, this is going to fail. Now, why would that fail? Why would we not be able to take the square root of a value? So if we have our parabolas, and I've got one that's up here, it's not going to have any zeros. It's not going to have any real roots. And so I'll end up with a value under here that's negative, and I can't take the square root of a negative value. So the quadratic formula will fail because there are no zeros. But also, if I just do that portion, that discriminant, and I get a negative value, I know there's no zeros. If I get 0, if I get square root of 0, which by the way is just 0, that means I have 1, 0. The vertex could be something like this. Maybe it's upside down as well. But it's the idea that the vertex is the only 0 on the parabola. But if I get a positive value, then I know I have 2 zeros. So the discriminant is what tells us, I'm going to just put a link here. The discriminant tells us how many zeros we have, or how many real roots. How many zeros? So if the discriminant is a negative number, no zeros. If the discriminant is 0, 1, 0. And if the discriminant is a positive value, we're going to have 2 zeros. And it's that plus and minus that gives us the 2 zeros. One by adding a certain value, and one by subtracting a certain value. Okay, so that's a lot of information. There's a lot of letters being flown around here. Let's do some practice. So we have a quadratic here that we've been asked to solve and find the zeros. Solve for the zeros in this quadratic is what it says. And I'd love to factor it because factored form, right, is the easiest way to solve for zeros, to find zeros. So we're going to do product and sum. So I need two values that multiply to make 10. So multiply to make 10 and add to make 8. Take your time. The factors of 10 are 1 and 10 or 2 and 5, and neither of those are going to add up to 8. This is why we're going to want to use the quadratic formula. Could I complete the square on this? Yes. Is it easy to complete the square on this one? Yes, because I can take half of b, which is going to be half of 8, which is 4. 4 squared is 16. It's easy to add and subtract 16. But why go through all that trouble when I can just plop down the quadratic formula? So x equals, and this is really good for you, the viewer, you should write this down. Writing down this formula over and over again is a great way to memorize it. So negative b plus or minus the square root of b squared minus 4ac. Now make sure your square root goes over that entirely because you want to remember what you're square rooting. It's also a proper way of writing. That is all over 2a. And I have a bit of a funny story. One of the very first times I was teaching this, when I was a very young and just up and coming teacher, I forgot the 2 in the denominator and taught my entire lesson and sent the class home with their homework. And when they get back, they said, "Sir, nothing matched. The answers in the back of the book are totally wrong." And I had to say, "Nope, tear up your notes. We're doing it again. I gave you the formula incorrectly." So here it is. We're going to place our values directly into it. That's the nice thing about the quadratic formula. It's just plug and play, man. We're just going to plug 8 in everywhere we see a b. So 8 goes there, and 8 goes there. We're going to plug a 1 in wherever we see the a, because, you know, my a is 1 in this one. I'm going to plug a 10 in wherever I see a c. And then my denominator is just 2 times a, which in this case is 2 times 1. All right, so it's just mathematics. It's just grab a calculator, you know? You want to do your stuff slowly. I know a lot of people do this and they try to do it all in one step on their calculator, and inevitably they make a mistake. And they blame it on, you know, something, "Oh, it didn't work," or "the calculator gave me the wrong answer." No, you're just trying to do too much at once. So 8 squared is 64. This is pretty easy, right? 4 times 10 is 40. And 2 times 1 is obviously 2. So we'll do the square root portion here. So 64 take away 40 is 24. And that's all over 2. Okay, there's actually 2 ways to continue from here. We can get what they call sort of the exact value, or we can get the decimal value, the inexact value. When I take the square root of 24, it's not going to be a super awesome number. It has a very long decimal value. So I'm going to split my lesson up at this point into 2 different ways that we can do this. And the first way I'm going to do is just with exacts. And you may not have seen simplifying a radical before. And if this just gets too complicated for you, just skip over to the right-hand side where I do it as a decimal. But this is called the radical sign. The square root is called a radical. And we don't really like gross decimal values. This is the whole reason why we keep things in fraction form instead of, you know, decimals. If we take our root 24, is there a way that we can simplify this with numbers that we know for sure have a square root? For example, 9 has a nice square root, 4 has a nice square root, 16 has a nice square root, and 24 can be made up of 4 times 6. And 4 is a value that I can take the square root of. I know what it is. So if we just take a look at that 24 as the two factors, 4 and 6, I'm going to take the square root of the 4, which is 2. So it can come out of the square root. Unfortunately, the 6 has to stay because, ew, gross, square root of 6 is not a nice number. But now what I can do is I can actually divide the 8 and the 2 by the 2 in the denominator here, and it really simplifies things for me for my zeros. I'll end up with negative 4 plus or minus root 6, which is much nicer than a gross decimal value. And so what I would say is my two zeros are negative 4 plus the square root of 6 and negative 4 minus the square root of 6. And this would, some people would say you should put the root first or you should put the constant first. Doesn't matter. Who cares? So these are my two zeros. Let's just be clear on this. These are two zeros that we could totally use. But if you don't like that or you don't really understand it, maybe you haven't practiced it enough, you can do it with decimal values. So the square root of 24 is 4.898979. So I'm going to just round to a certain value here. So 4.898979. And we'll just kind of leave it at that. It could go on. There's other numbers after that, but we'll just keep it nice and simple, right? Oh, gross. So what does that mean? Well, it means I have two different possible answers. 8 plus that value, 4.898979 over 2. Or it's negative 8 minus 4.898979, I almost ran out of room, over 2. And this is not fun math. This is why people use simplified radicals, as I showed you on the left. What would you rather write, 4 root 6 or this crap? All right, well, let's do the math. We get negative 1.55. And I'll just put approximately. Different approximate signs you can put. There's squiggles, there's the dot on the equal sign, whatever it is you are used to using. And then on the other end of the spectrum, we get negative 6.4495. I'll just round to that. And those are my two zeros. Now there's no way that we would have gotten these two zeros nicely from this standard form equation. It looks harmless, right? 1, 8, and 10. But it doesn't factor. We could have completed the square, and when we did complete the square and solve using completing the square, we still would have gotten these as answers. These are the two zeros. And if we wanted to check that, negative 4 plus root 6 is going to give me negative 1.55, or at least extremely close to it, depending on the rounding. But it sure is much nicer to write it as these numbers. So again, I've got two zeros by using the quadratic formula instead of completing the square or factoring. Now, if you'd like to see that done one more time, I know the video is already quite long, so you can certainly pause it here and just practice on your own. But here we have a quadratic that's a little bit more complicated. And what we've been asked is, when is the parabola of this quadratic here, when is that below 5? So I have a parabola that opens upward, and I've been asked, when is that below the number 5? Some arbitrary value right here, just 5. So what we're going to do is we're going to set the y value to 5, and we're going to solve for the roots. This is when it's not zeros anymore. This is when it's roots. I'll bring the 5 over to the other side. So let's subtract 5 on both sides, and I'll get negative 15. So we now have a different equation to work with. The hope is that it would factor. 3 times negative 15 is negative 45. The factors of 45 that add to 7. Not going to happen because it doesn't factor. So what we're going to do now is we're going to complete the square and solve, right? But completing the square on this is exactly what I showed you before. I'm going to get 7 over 2, and then I'm going to have to, 7 over 3, and then I'm going to end up with 7 over 6 and try to square root, and everything's just so gross. So I'm just going to use the quadratic formula. So write it down again, folks. Write down that quadratic formula again. So it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There we go. And it's plug and play. We're just going to replace the values in where they're supposed to go. So it's negative 7 plus or minus. And if you're really good at, mathematics, you can square this as you go. 7 squared is 49. So when I plug that in there, it's going to say 7 squared, but we all know 7 squared is 49. That's going to be 4 times a times c. Don't forget your positives and negatives. A lot of people end up getting answers wrong when they're doing the quadratic formula because they're going too fast, or they're forgetting their positives, negatives, or brackets, or sort of bedmass rules. So we're going to take a look at the math underneath that square root sign. We're going to need to make sure we copy everything down correctly. So we've got a -7 plus or minus the square root. The 49 is still there. And we're going to have a positive 180 by multiplying all of that out. The denominator is a nice and simple 6, and we're just going to continue doing our arithmetic as we go. 180 plus 49, 229. And we could look for a nice clean radical with the 229. I'm just going to go ahead and use decimal values, even though they're kind of gross. So we've got -7 plus or minus 15.13. I'll just round to 2 decimal places, 15.13, and that's all over 6 still. And that means we've got our 2 zeros. I'll just do that up here. We know that x is going to be -7 plus 15.13 divided by 6, or x is going to be equal to -7 minus that same value divided by 6. And those final values are approximately 1.355 and -3.688. -3.688. Now what does that mean? Well, it means that my parabola is below the value of 5. Let's go back to the drawing I had up here. My parabola is below the value of 5 between those 2 zeros. You have to understand which one's the left-hand side, which one's the right-hand side. So -3.68 would be over here. So right here. So that would be an x value of -0.3, what did I say, 68. And then 1.355. So the other one over here would be 1.355. And so we would discuss that as an answer that this particular parabola is below 5 between those two values. You could put a therefore statement or any sort of thing like that. So I say therefore or something along those lines. And while it does look a bit messy, this is a little bit more math and square roots and fractions than we're probably used to, we didn't end up having to deal with the crazy completing of the square of this particular standard form quadratic. When you have the quadratic formula, it's easy to memorize. You just plug your values in and do the math. You just have to be really cautious of all of your pluses, all of your minuses, and your general everyday arithmetic. Okay, bit of a marathon on that one, but a very important topic. Khan Academy has a wonderful playlist on quadratic formula and how to use it and when to use it and all of that. If you liked this video, by all means, give me the thumbs up. If you have some constructive criticism, leave me a comment. And if you want to subscribe to my channel, I'd really appreciate it. Thanks very much, and have yourself a great day. This cutie over here is Mr. Squirrel. He approves this video. My name is Mr. Brash, and I'll see you in my next video.